The clumsy beginning. Margaret, Maggie, Chun had earned her unfortunate reputation honestly. In the first 3 months at St. Mary's Hospital in London, she had knocked over medication trays 7 times, mixed up patient charts twice, and once accidentally wheeled a patient into the wrong operating theater. The head matron, Sister Elizabeth Thornberry, had taken to calling her Hurricane Margaret behind her back, though never quietly enough that Maggie didn't hear. It was October 1940, and the London Blitz had transformed the hospital into a constant state of controlled chaos. Bombs fell nightly, shattering windows and sending tremors through the ancient building's foundations. Injured civilians poured through the doors in waves, their bodies torn by shrapnel and crushed by collapsing buildings. Yet somehow, in all this mayhem, Maggie Chun still managed to stand out as particularly disastrous. "Chun," Sister Thornberry's voice cut through the emergency ward like a scalpel. "That's the 3rd for you botched this evening. At this rate, we'll run out of supplies before midnight." Maggie's hands trembled as she looked at the needle she'd just been attempting to find a vein in an elderly man's collapsed arm. Her face burned with shame as the other nurses exchanged knowing glances. Sarah Mitchell, the star pupil who could insert in 4 blindfolded, smirked from across the room. "I'm sorry, sister. His veins are very fragile in the light. Excuses won't save lives, Chun. Perhaps you should stick to changing bedpans." Sister Thornberry snatched the needle away and completed the insertion in one fluid motion. The elderly patient didn't even flinch. As Maggie retreated to the supply closet to fetch more linens, she heard the whispers that had become her constant companion. "How did she even graduate? My grandmother has steadier hands. She'll kill someone before the Germans get the chance." What they didn't know, what Maggie herself barely understood, was that her clumsiness masked an unusual gift. While her hands failed her, her mind worked differently than others. She saw patterns where others saw chaos, connections where others saw separate problems. As she restocked supplies that night, her eyes kept returning to the glass bottles of blood lined up in the refrigerated unit. The bottles had always bothered her. They were heavy, fragile, and required careful handling during transport. In the chaos of the Blitz, she'd watched 3 bottles shatter just that week, their precious contents, potentially life-saving blood, spreading uselessly across the floor. Each broken bottle represented a life that might not be saved, a soldier or civilian who would go without. The problem gnawed at her throughout her shift. When the air raid sirens wailed at 2 a.m, Maggie was in the storage room, studying a broken bottle. As everyone else rushed to the basement, she turned the thick glass over in her hands, thinking about its weight, its rigidity, its absolute lack of adaptability. "Chun, what in God's name are you doing? Get to the shelter." Dr. William Harrison stood in the doorway, his usually neat hair wild from a 16-hour surgery shift. He was young for a surgeon, barely 30, and had a reputation for patience that contrasted sharply with Sister Thornberry's iron discipline. "The bottles, doctor, they're too fragile. We lose so much blood to breakage, especially during transport to field hospitals. The soldiers in France, they're dying not because we don't have blood, but because we can't get it to them intact." An explosion rattled the building. Plaster dust drifted down from the ceiling. Dr. Harrison glanced toward the shelter, then back at Maggie's intense expression. Something in her face made him pause. "Go on. What if—" Maggie hesitated, suddenly aware of how absurd her idea might sound. "What if we didn't use glass at all? What if we used something flexible? Something that couldn't shatter? Like what? Rubber? It's not sterile. Metal? Too heavy. I don't know yet, but there must be something." She held up the broken bottle, its jagged edges catching the dim emergency lighting. "This is wrong. There's a better way. I can feel it." Another explosion, closer this time. The lights flickered. Dr. Harrison grabbed her arm. "Time to go. But Chin, don't dismiss that thought. Sometimes the worst nurses make the best inventors, precisely because they see all the ways things can go wrong." As they hurried to the shelter, Maggie clutched the broken glass, her mind already racing through possibilities. She didn't know it yet, but that moment of clarity would change military medicine forever. Her clumsiness had finally revealed its purpose. She was meant to break things so she could imagine better ones. The impossible problem. 3 weeks after that night in the storage room, Maggie Chen had become even more of a liability. Her preoccupation with the blood storage problem had made her more distracted than ever. She'd burned herself on an autoclave, tripped over a stretcher, and somehow managed to order 200 bedpans instead of 20, an error that had cost the hospital dearly and earned her a formal warning from Sister Thornberry. One more incident. Chun, and I'll have you transferred to the administrative offices. At least there, your incompetence will only harm paperwork, not people. Yet despite her mounting failures, Maggie couldn't let go of the blood bottle problem. At night, after her shifts, she'd stay late in the hospital library, reading everything she could find about blood storage, preservation, and transport. The science was still relatively new. Blood banking had only become practical in the late 1930s, and most of the literature focused on refrigeration and typing, not container design. The numbers haunted her. Reports from a North African campaign showed that nearly 30% of transported blood supplies arrived damaged or spoiled. In naval operations where ships pitched and rolled, the percentage climbed even higher. Each broken bottle represented not just lost blood, but lost time, lost resources, and ultimately lost lives. Dr. Harrison had become an unlikely ally. Unlike the nursing staff, who saw only her failures, he seemed intrigued by her unconventional thinking. He began leaving medical journals on her station, articles marked with notes like, "Thought you'd find this interesting or relevant to your glass problem." One evening in November, he found her in the basement near the boiler room, surrounded by an odd collection of items: rubber gloves, canvas bags, wax paper, cellophane from cigarette packages, and what appeared to be a bicycle inner tube. "Chun, what on earth are you doing down here? Sister Thornberry is looking for you." Maggie jumped, scattering her materials across the concrete floor. "Doctor, I thought if I could test different materials." "For blood storage?" He knelt down, picking up the rubber glove. "Have you actually been experimenting?" "Not with real blood, just water. Testing for leaks, flexibility, sterilization potential." She gestured to a makeshift setup involving a wash basin and various containers. Everything leaks or degrades too quickly or can't be sterilized properly. Rubber has chemicals that might contaminate blood. Cellophane tears. Canvas absorbs liquid. I thought maybe wax coating, but it flakes off. Dr. Harrison studied her workspace with growing interest. "You've been systematic about this." "I've been failing systematically. You mean?" Maggie's shoulders slumped. Maybe Sister Thornberry is right. Maybe I should accept that some problems don't have solutions. Or maybe you haven't found the right materials yet. He sat down on an empty crate, unmindful of his clean white coat. "Tell me what properties your ideal container would need." Maggie blinked, surprised to be taken seriously. She began counting on her fingers. "Flexible, so it can't shatter. Lightweight for easy transport. Transparent, so you can see the blood and check for clotting or contamination. Sterilizable with heat or chemicals. Non-reactive, so it doesn't affect the blood chemistry. Sealable to prevent contamination. And it needs to be manufacturable at scale. We'd need thousands, maybe millions eventually." "That's quite a list." "That's an impossible list." Maggie picked up the bicycle tube, squeezing it in frustration. "I'm chasing something that doesn't exist." Dr. Harrison was quiet for a moment, watching her manipulate the rubber. "What about plastics?" "Plastics. They're relatively new, experimental. But I read something recently. Let me think. About a polymer called polyvinyl chloride, PVC. It was in a chemistry journal. Flexible, transparent, can be heat sealed. They're using it for industrial applications, electrical insulation mostly." Maggie's pulse quickened. "Would it be safe for blood contact?" "I have no idea. That's the question, isn't it?" He stood up, brushing dust from his coat. "But I know someone who might. My university roommate works at a chemical laboratory in Cambridge. They've been experimenting with plastics for military applications, gas masks, protective gear. I could write to him." "Would you?" "Really?" Hope flickered in Maggie's chest. "Unfamiliar and slightly terrifying. On one condition. You stop hiding in the basement and start showing up on time for your shifts. Sister Thornberry is already looking for reasons to dismiss you, and brilliant ideas don't matter much if you're not here to implement them. Brilliant ideas? Maggie laughed bitterly. Doctor, I'm the worst nurse in this hospital. Everyone knows it. You're the worst at traditional nursing tasks, he corrected. But you're seeing a problem that experienced, competent nurses have looked at for years without questioning. That's not incompetence, Chun. That's innovation. The question is whether you have the discipline to see it through. A bell rang upstairs, the signal for incoming casualties. They could hear footsteps thundering overhead, voices shouting instructions. Dr. Harrison headed for the stairs, then paused. Sometimes being the worst at what everyone expects makes you the best at what no one else imagines. Think about that. As he disappeared up the stairs, Maggie gathered her materials slowly, carefully. For the first time since she'd arrived at St. Mary's, she felt something beyond shame and frustration. She felt purpose. The worst nurse in the hospital was about to attempt the impossible. The letter from Cambridge. December brought a cold so bitter that ice formed on the inside of the hospital windows. Maggie's hands, always clumsy, became even more unreliable in the freezing temperatures. She dropped instruments, fumbled with bandages, and on one memorable occasion, accidentally locked herself in the medicine cabinet while trying to retrieve aspirin. Chun, you're a walking disaster, Sister Thornberry declared after that incident, her patience finally exhausted. I'm reassigning you to inventory duty. At least in the storage rooms, you can only harm inanimate objects. It was meant as punishment, but Maggie received the news with secret relief. Inventory duty meant hours alone with medical supplies, time to think, and access to the refrigeration units where blood was stored. She could observe the bottles, study how they were handled, and document every instance of breakage without the constant pressure of patient care hovering over her shoulder. The weeks crawled by with no word from Cambridge. Maggie began to lose hope. Dr. Harrison was kind, but he was busy. 16-hour surgery shifts, endless casualties, and the grinding exhaustion of war. Perhaps he'd forgotten his promise. Perhaps his friend had dismissed the inquiry as absurd. Perhaps plastic simply couldn't work for blood storage. Then, on a gray morning in mid-December, Dr. Harrison burst into the storage room where Maggie was counting morphine ampoules. His face was flushed with excitement, and he waved a thick envelope like a flag. He wrote back. Chun, he actually wrote back, and you need to see this. Maggie abandoned her counting. Morphine vials forgotten. Her hands shook as she took the letter. Not from nervousness this time, but from anticipation. The letter was from Dr. James Whitmore, a chemist at Cambridge's War Research Laboratory. His handwriting was precise, scientific, filled with chemical formulas and technical specifications that made Maggie's head spin. But the core message was clear. PVC might work. Listen to this part, Dr. Harrison said, reading over her shoulder. Polyvinyl chloride has several properties that make it potentially suitable for medical applications. It can be manufactured in thin, flexible sheets. It's transparent. It can withstand steam sterilization at 120 degrees Celsius. Most importantly, preliminary tests suggest it's relatively chemically inert. It doesn't readily react with aqueous solutions. Aqueous solutions, that includes blood? Maggie's mind raced ahead. Presumably. But he's cautious here, see? Dr. Harrison pointed to a paragraph. However, I must emphasize that PVC has never been tested for blood contact. The potential for contamination, chemical leaching, or clotting complications is unknown. Any such application would require extensive testing before human use. Can we get samples? Could we test it? Dr. Harrison flipped to the second page. He anticipated that question. He's willing to send sample sheets of medical-grade PVC. Apparently, they've been developing it for other purposes. But Chun, he's also warning us that this is highly experimental. If something goes wrong, if the plastic contaminates blood, if it causes adverse reactions, we could be responsible for harming soldiers rather than helping them. Maggie sat down heavily on a crate of bandages. The weight of the undertaking suddenly pressed down on her. She was the worst nurse at St. Mary's, barely trusted to change linens, and now she was considering developing a new medical device that could affect thousands of lives. Maybe I'm not the right person for this, she said quietly. Maybe someone more experienced, someone competent. Stop. Dr. Harrison's voice was firm. Do you know why incompetent people never innovate? Because they don't see the problems. They follow procedures without questioning them. You see problems everywhere you look because you're constantly colliding with them. That's not a weakness. Chun, that's the first requirement for innovation, recognizing that something is broken. He sat down beside her, the letter between them. I won't lie. This is dangerous territory. We'll need to be methodical, careful, thorough. We'll need to test everything multiple times. We'll need to document every step. And we'll need to be prepared for failure, possibly repeated failure. But if we succeed, we could save lives, Maggie finished. Thousands of them, maybe tens of thousands. He looked at her seriously. So I'll ask you directly, are you willing to try? Are you willing to take the risk of being wrong, of failing, of potentially making things worse in the attempt to make them better? Maggie thought about the broken bottles she'd cataloged over the past weeks. She thought about the reports from North Africa, the wasted blood, the soldiers who died for lack of transfusions. She thought about being called the worst nurse, about Sister Thornberry's contempt, about the whispers that followed her through the corridors. Then she thought about Dr. Harrison's words. Sometimes being the worst at what everyone expects makes you the best at what no one else imagines. Yes, she said, I'm willing to try. Dr. Harrison smiled and stood up, extending his hand to help her up. Then let's write back to Cambridge and request those samples. And Chun, start keeping detailed notes on everything. If this works, people want to know how the worst nurse in London managed to revolutionize battlefield medicine. As Maggie returned to her morphine count, the letter safely tucked in her pocket, she felt something shift inside her. Her clumsiness hadn't vanished. She immediately knocked over 3 vials while recording inventory. But for the first time, it didn't feel like failure. It felt like the necessary friction between who she was and what the world needed her to become. Outside, bombs continued to fall on London. Inside, in a storage room that smelled of antiseptic and fear, a revolution in medical technology had just begun. The experiments. The plastic samples arrived in January 1941, delivered in a brown paper package that Maggie signed for with trembling hands. She'd been reassigned to night inventory duty, Sister Thornberry's latest attempt to minimize her contact with actual patients, which meant she had the storage areas largely to herself between midnight and dawn. Perfect conditions for unauthorized medical experimentation. Dr. Harrison met her in the basement laboratory at 1 a.m, having just finished an 18-hour surgery shift. His eyes were red with fatigue, but his excitement was palpable as they unwrapped the Cambridge package together. Inside were 6 sheets of clear plastic, each about the size of a book page, along with detailed specifications from Dr. Whitmore. The material was remarkably thin, perhaps a millimeter thick, and surprisingly flexible. When Maggie held a sheet up to the light, she could see through it almost as clearly as glass. It's beautiful, she whispered. It's improving, Dr. Harrison cautioned, but he was smiling. Now comes the hard part. We need to design experiments that will tell us whether this material is safe for blood contact. They spent the next hour sketching plans on the back of requisition forms. The experiments would need to be methodical, progressing from simple to complex. First, chemical compatibility. Would the plastic react with blood components? Second, sterility. Could the material be sterilized without degrading? Third, durability. Would the plastic hold up under the stresses of transport and storage? Fourth, functionality. Could they actually construct a working container from material? And finally, if all those tests succeeded, they'd need to test with actual blood storage. We'll start with saline solution, Dr. Harrison decided. Similar density to blood, but if something goes wrong, we're not wasting precious blood supplies. The early experiments were frustrating. Maggie's first attempt to construct a container from the plastic sheets were disasters. She tried sewing the edges together. The plastic tore. She tried gluing them. The glue dissolved the plastic. She tried melting the edges together over a candle flame. She set the plastic on fire and nearly triggered the smoke alarms. Chen's trying to burn down the hospital now, she muttered after the third fire incident. That would be a new low even for me. But Dr. Harrison, drawing on his surgical experience, suggested a different approach. Heat sealing. Using a modified cautery iron from the surgical suite, they could melt the plastic edges together in a controlled way, creating sealed seams. It took 2 weeks and dozens of ruined sheets before Maggie created her first successful prototype, a simple rectangular pouch, sealed on 3 sides, with the 4th side left open for filling. It wasn't elegant. The seams were uneven, the corners wrinkled, but it held saline solution without leaking. "It works," she breathed, holding the bulging plastic pouch up to the light. "It holds water," Dr. Harrison corrected. "That's step 1. Now we test whether it can be sterilized." The sterilization test revealed the first major problem. While the plastic survived steam sterilization at lower temperatures, higher temperatures, the standard 121 degrees Celsius required to kill bacterial spores, cause the plastic to warp, and the seals to weaken. "We're stuck," Maggie said after their 5th failed sterilization attempt. "We can either sterilize it properly and destroy it, or preserve the structure and risk infection. There must be middle ground." Dr. Harrison studied the warped pouch thoughtfully. "What if we adjust the sterilization parameters? Lower temperature, longer duration? Or what if we use chemical sterilization instead?" They spent the next 3 weeks testing variations. Ethylene oxide gas sterilization worked, but wasn't practical for field conditions. Alcohol sterilization was insufficient for surgical standards. Finally, they discovered that a careful combination of pre-sterilized plastic sheets, aseptic manufacturing techniques, and lower temperature steam sterilization could work if they were meticulous about every step. "It's possible," Dr. Harrison concluded, examining their latest batch of pouches. "Difficult, requiring careful protocols, but possible. Now for the real test," Maggie said quietly. "Actual blood." They requisitioned outdated blood samples that were scheduled for disposal anyway, blood that was no longer suitable for transfusion but could be used for testing. Maggie carefully filled her plastic pouches with a dark red liquid, sealed them, and placed them in the refrigeration unit next to the traditional glass bottles. Every day for the next 2 weeks, she monitored the samples. She checked for leakage, for discoloration, for clotting, for any sign that the plastic was reacted with the blood. She compared her plastic pouches to control samples in glass bottles, looking for differences. The pouches performed adequately. The blood remained liquid, showed no obvious signs of contamination, and didn't clot any faster than the glass-stored samples. But adequate wasn't the same as safe for human use. "We need proper laboratory testing," Dr. Harrison said, studying Maggie's careful notes. "Chemical analysis, bacterial cultures, compatibility testing with different blood types. This is beyond what we can do in a hospital basement." "How? Who would take us seriously? I'm an incompetent nurse, and you're an overworked surgeon. We have no credentials in research, no laboratory facilities, no funding." "We have this." Dr. Harrison tapped her notebook, filled with weeks of careful observations and measurements, documentation, evidence of systematic experimentation. "And we have Dr. Whitmore at Cambridge. If we can convince him that this is worth pursuing." He trailed off, looking at the plastic pouches lined up on the laboratory bench. They looked so simple, so fragile, so unlikely to change anything. Yet Maggie could see in them something that didn't exist in the glass bottles. The potential for survival. "Write to him," she said. "Tell him what we've done. Show him the data. Ask him if his laboratory could run proper tests. And if he says no," Maggie thought about that. She thought about being the worst nurse, about every failure, every mistake, every moment of humiliation that had brought her to this point. Then she thought about the soldiers in North Africa, the sailors on ships, the pilots in the sky, all of them bleeding, all of them needing blood that would never reach them intact because the containers were wrong. "Then we keep trying," she said, "because the worst nurse in London might be the only person stubborn enough to refuse to accept the impossible." The breakthrough, March 1941, brought unexpected hope. Dr. Whitmore's response to their experimental data was enthusiastic enough to arrange a meeting in Cambridge. Dr. Harrison secured 2 days of leave, and through bureaucratic maneuvering that Maggie didn't fully understand, arranged for her to accompany him as his research assistant. Your research assistant? Sister Thornberry's eyebrows nearly disappeared into her cap. Dr. Harrison, Chun can barely assist with basic nursing tasks. What possible research could she assist with? Medical innovation research, he replied smoothly, related to trauma care in field conditions. The details are somewhat technical. Sister Thornberry looked skeptical, but was too understaffed to argue. 2 days. If she's not back by Monday, she's dismissed. The train journey to Cambridge took 4 hours through countryside marked by war, bomb craters in fields, anti-aircraft guns on hills, cities scarred by German bombers. Maggie clutched a briefcase containing their notebooks, sample pouches, and photographs of their experiments, feeling like an imposter traveling to meet real scientists. Stop fidgeting, Dr. Harrison said. You've done solid work. Stand behind it. I'm the worst nurse in London pretending to be a medical researcher. You're the person who identified a critical problem and worked systematically to solve it. That's the definition of a researcher. Cambridge University's chemical laboratory was a stern Victorian building that smelled of sulfur and ethanol. Dr. Whitmore met them in his office, a cluttered space dominated by bookshelves and chemical models. He was younger than Maggie expected, perhaps 35, with ink-stained fingers and an intense, focused manner. Dr. Harrison, excellent to see you again. They shook hands. And you must be Nurse Chun. Your documentation is impressive, very thorough, very systematic. Rare to see such careful methodology outside formal research settings. Maggie felt heat rise in her cheeks. Thank you, sir. I learned the importance of documentation the hard way by making many mistakes. Whitmore smiled. The best scientists are the ones who've made the most instructive mistakes. Come, let me show you what we've been working on. His laboratory was filled with equipment Maggie couldn't identify. Strange glass apparatus, electrical instruments, rows of bottles containing substances in every color. But what caught her attention was a table covered with plastic pouches identical to her prototypes, alongside complex testing equipment. We've been running your blood storage concept through extensive analysis, Whitmore explained. Chemical composition, bacterial growth, hemolysis rates, clotting factors, everything we could think of to test safety and efficacy. And Dr. Harrison leaned forward. Whitmore pulled out a thick folder. The results are complicated. The good news, PVC appears to be chemically inert with blood. We've seen no significant contamination, no toxic leaching, no adverse reactions in preliminary tests. The plastic is transparent enough for visual inspection. It can be sterilized, though, as you discovered, it requires careful protocols. That's excellent news, Maggie said, hardly daring to breathe. However, Whitmore's expression grew serious. The challenges are significant. Manufacturing consistency is difficult. We've seen variation in seal strength between batches. The sterilization protocols are more complex than standard procedures. And most critically, we don't yet have data on long-term storage. How does blood stored in plastic perform after a week? A month? Does the plastic degrade over time? Do components in blood gradually react to the polymer? How long would those tests take? Dr. Harrison asked. Properly? 6 months to a year. And that's just laboratory testing. Human trials would take longer. Maggie's heart sank. Soldiers are dying now. We don't have a year. Which is why I made a proposal to the War Office. Whitmore pulled out another folder, this one stamped with official seals. Accelerated testing protocols. Abbreviated trials. Emergency approval pathways that bypass standard procedures. It's risky. If something goes wrong, if the plastic causes complications we haven't anticipated, the consequences could be severe. But if it works? Maggie asked. If it works, we could have plastic blood storage bags, your blood bags, in field hospitals within 6 months. Not the full-scale manufacturing yet, but enough for meaningful trials. Enough to prove the concept. The room fell silent. Maggie looked at the pouches on the table. Her crude prototypes transformed by professional manufacturing, but still recognizable as the same basic idea. A simple, flexible container. Nothing revolutionary in its conception, yet potentially transformative in its application. What do you need from us? Dr. Harrison asked. Your continued cooperation, more observational data from hospital settings, documentation of every break, every loss, every situation where rigid containers fail. We need to build a case that the current system is dangerous enough to justify rapid deployment of an improving alternative. I could provide that, Maggie said. I've been documenting breakage rates for months, and I can expand the observations, create systematic protocols for data collection. Excellent. I also need you to continue your experimental work at St. Mary's. We can provide better materials, proper sealing equipment, sterile working conditions. You'll essentially become an extension of this laboratory, testing our prototypes in real hospital environments. Maggie glanced at Dr. Harrison in alarm. I'm not sure Sister Thornberry will. Leave Sister Thornberry to me, Harrison interrupted. If this has War Office backing, she'll cooperate. She has no choice. Whitmore nodded. I'm preparing official documentation designating Nurse Chin as a research collaborator on a classified medical project. That should provide sufficient authority. Classified? Maggie felt the situation spiraling beyond her comprehension. It's just a plastic bag. It's a potential revolution in battlefield medicine, Whitmore corrected. The military takes such innovations very seriously. If successful, this could change how we deliver medical care in war zones. And Miss Chun, may I call you Margaret? Maggie, then, you should understand something. If this works, you won't be remembered as the worst nurse in London. You'll be remembered as the woman who saved thousands of soldiers' lives. That's a heavy responsibility. Are you prepared for it? Maggie thought about her months of failures, her clumsiness, her constant mistakes. She thought about Sister Thornberry's contempt and the whispers that followed her through hospital corridors. She thought about being terrible at what everyone expected and potentially excellent at what no one had imagined. No, she said honestly, I'm not prepared. I don't feel qualified or capable or remotely ready for this responsibility. But I'll do it anyway because someone has to. Whitmore smiled. That's the right answer. The wrong person for an impossible task often turns out to be exactly the right person, precisely because they're too naive to know it can't be done. As they left Cambridge that evening, the setting sun painting the ancient university buildings gold, Maggie clutched a new folder of official documents that transformed her from failed nurse to medical researcher. Nothing had changed. She was still clumsy, still prone to mistakes, still the worst at traditional nursing. But everything had changed. The worst nurse in London was about to help win the war. The legacy. By June 1942, Maggie Chin was still dropping things. Her hands hadn't magically become steady. Her spatial awareness hadn't improved. And just last week she'd managed to lock herself in the supply closet for the third time. Sister Thornberry still sighed heavily whenever Maggie approached, though now the sighs were tinged with reluctant respect rather than pure exasperation. Because pinned to Maggie's uniform, next to her nursing badge, was a small silver pin bearing the seal of the Royal Army Medical Corps, official recognition of her contribution to the war effort. The War Office had classified most details, but word had spread through St. Mary's. The worst nurse in London had invented something important. The blood bags, officially designated flexible blood storage containers, Type A, had entered large-scale production in March. The first 1,000 units had been deployed to North Africa, where Field Marshal Montgomery's forces were engaged in brutal desert warfare against Rommel's Afrika Korps. The results exceeded even Dr. Whitmore's optimistic projections. Breakage rates dropped from 30% to less than 2%. Transport was easier, storage more efficient, and field medics could carry multiple bags where they previously managed only 1 or 2 bottles. Most crucially, soldiers who would have died for lack of blood transfusions were surviving. Dr. Harrison brought Maggie the field reports, reading them aloud in the hospital basement where they conducted their first experiments. His voice caught as he read a letter from a medical officer. The flexible containers have transformed our ability to provide emergency transfusions. Yesterday, during a tank engagement, we performed 6 transfusions in 30 minutes using bags that survived a 2-mile transport across rough terrain. under the old system. We had been lucky to have one intact bottle. Please convey my deepest gratitude to whoever invented these remarkable devices. They are, without exaggeration, saving lives every day. Maggie's eyes filled with tears. They're actually working. Better than working. They're revolutionary. Dr. Harrison set down the letter. The Americans are already requesting manufacturing specifications. The Canadian forces want immediate deployment. Even the Russians have expressed interest through diplomatic channels. All because I kept breaking bottles, Maggie said, half laughing, half crying. All because you paid attention to what you broke. Dr. Harrison's expression grew serious. Maggie, there's something else. The Royal College of Surgeons wants to honor you. Public ceremony, medal presentation, the full recognition. Maggie's stomach clenched. No, please, no. You can't avoid this. What you've accomplished. Is it mine to claim? She gestured around the basement laboratory. You believed in me. Dr. Whitmore did the real science. The manufacturers made it possible. The soldiers are the ones using it, proving it works. I just noticed something was wrong and was too stubborn to let it go. That's called innovation, Maggie. That's called genius. It's called being so clumsy that I couldn't help but see the fragility in everything. She picked up one of the plastic blood bags from a shipping crate destined for France. It was heavier now, reinforced with better seals and standardized fittings, but the core concept remained unchanged. A flexible container. Simple, obvious in hindsight. I'm still the worst nurse here, she continued quietly. Last week I gave a patient the wrong meal tray. Yesterday I knocked over an entire cart of surgical instruments. This morning I called a patient by the wrong name 3 times. Sister Thornberry still watches me like I'm a disaster waiting to happen. And she's not wrong. Dr. Harrison said with a gentle smile, You are a disaster. An extraordinarily productive disaster. The kind that changes the world. Over the following months, as production ramped up and the blood bag spread across every theater of war, Maggie remained at St. Mary's, still working inventory, still making mistakes, still earning exasperated sighs from Sister Thornberry. But now, when she walked through the hospital corridors, the whispers had changed. That's Chun, the one who invented the blood bags. Really? Her? But she's so... I know, but apparently terrible nurses sometimes make excellent inventors. The war continued for 3 more years. Maggie's blood bags became standard equipment in every Allied field hospital, every ambulance, every medical facility, from the beaches of Normandy to the jungles of Burma. Estimates suggested that the bags enabled successful transfusions for over 50,000 soldiers who would otherwise have died from blood loss. 50,000 lives, saved by a clumsy nurse who couldn't stop breaking bottles. In 1945, after the war ended, Maggie finally accepted a commendation from the Royal College of Surgeons. She stood on stage in her nurse's uniform, uncomfortable with the attention, while distinguished physicians praised her innovation and vision. In her acceptance speech, Maggie spoke for less than 2 minutes. I'm told I saved lives, but I didn't save them through skill or competence or excellence at my profession. I saved them by being spectacularly bad at my job, by breaking things, by noticing problems that better nurses had learned to work around. The lesson isn't that incompetence leads to innovation. The lesson is that sometimes the people who struggle most with a system are the ones most likely to imagine better systems, because they can't help but see the flaws. I was the worst nurse at St. Mary's Hospital. In some ways, I still am, but being the worst gave me permission to question what everyone else accepted. And that question, why are we doing it this way, turned out to be more valuable than any amount of technical skill. So to anyone out there who feels like they're failing, like they're the worst at what they do, like their clumsiness is a curse, pay attention to what you break. Study your failures. They might be showing you something that competence has made invisible. Your disaster might be someone else's breakthrough. The audience applauded. Maggie returned to her seat, relief flooding through her. It was over. She could return to St. Mary's, to her inventory duties, to her comfortable obscurity. But Dr. Whitmore caught her arm as she left the stage. Maggie, I have a proposal. The chemical laboratory at Cambridge is expanding its medical applications division. We need someone who understands both clinical realities and innovative thinking. Someone who knows how to fail productively. Would you consider joining us? Me? But I'm not a scientist. I barely passed chemistry in nursing school. You're not a traditional scientist. You're something potentially more valuable, a practical innovator. Someone who sees problems from the user's perspective and doesn't get trapped by theoretical constraints. Maggie looked back at the stage, at the assembled physicians and researchers, all of them competent, educated, successful. Everything she wasn't. Then she thought about the basement at St. Mary's, the broken bottles, the moment she'd first imagined something better. I'll still make mistakes, she warned. I'll still break things. I'll still be clumsy and forgetful and occasionally lock myself in storage closets. Dr. Whitmore smiled. I'm counting on it. The world has plenty of careful scientists who follow procedures perfectly. What we need are people who break procedures just often enough to discover better ones. So what do you say? Will the worst nurse in London become the worst scientist in Cambridge? Best worst scientist, Maggie corrected and shook his hand.